This is the typical meal. I would like to show you the main streams that they are introduced into the meal. Of course, we introduce the fuel. It can be coal, or it can be the mixture of coal and biomass. Also, we introduce the cold air and hot air. The aim is to control the temperature inside and the temperature in the outlet of the meal. According to our experience, it is between 90 to 130 degrees of Celsius, depending on the fuel. Also, we want to keep the flow rate by meal fan. But as you can see here, there are different sources of let's say temperature. We introduce the hot air, but also the meal balls by friction, let's say, the produce the energy or increase the temperature inside, simply said, inside the chamber. This number represents the points where we already measure the temperature in the meal, and also we collect the gaseous samples and analyze the concentration of gaseous compounds inside the meal atmosphere. And if we consider especially now focus only on the meal, if we would like to say that the way of ignition in meal, so we can distinguish between two possible ways. The first is hot surfaces, came from friction. As I said, that the meal ball by friction increase the temperature in some specific areas in the meal. Sorry. The second way of hot surfaces is the warming of meal before the meal start up. This is the typical process in meal engineering. Before meal startup, we have to heat up the meal to increase the temperature inside inside the meal. The another already explained the inerting meal by hot steam before a period removal. But also if some failure of the air temperature control exists, we can also unexpectedly increase the temperature inside the meal. So you can see the descriptions of the ignition, the ways of ignition in the meal, and also the ways of ignition from hot gases in the meal. I would like to underscore such thing, that the temperature, the temperature of the hot air that is introduced into the meal is approximately 300 degrees of Celsius. So it is very obvious that locally the temperature inside the meal can be in such level. If we compare it with the measured temperature of the meal in a specific points, that means the air introduced to the meal, and the temperature at the grinding balls, temperature under the grinding balls, at the separator, and the pipe to the burner. So this is the place, in fact, the outlet of the meal. We notice that in the specific accidents, especially when the meal is turn on or turn off or start up, the temperature can increase in such specific points. Also, it is not end of the story. We also detect the concentration of gaseous compounds inside the meal atmosphere, especially carbon monoxide and methane. As you know, they are very combustible gases, and we consider the few moments, specific moments in the meal processing. That's mean turning off, starting the steam system. This is the inerting when we introduce the steam inside the meal. The C is the closing of the steam system. The D is the moment when we again start the meal fan, and after that we start the meal, and the balls are rotated inside the meal. And also important, very important point is emergency stop of the meal, and especially in such moment we observed the significant drop of the carbon monoxide. Uh, Also, we noticed that the increase of combustible gases in the inerting time. Of course, in such, let's say, atmosphere, the concentration is not so high, is the level of ppms, but we can imagine that in some specific areas, the concentration of the combustible gases can be even higher, because we collected from the specific points, but in a specific area, the concentration even can be higher, so it increase the probability of explosion. And after that, if we compare such knowledge and such experience with the explosion parameters, especially if we focus on the minimum ignition temperature of dust layer, we can notice it's very clear that in case of the biomass, the minimum ignition temperature is even lower than 300 degrees of Celsius. Comparing to the coal, it is more than 400, but for, let's say, olive pomace, it can be even 270 degrees of Celsius. So this temperature, let's say, is easy to obtain inside inside the meal. So the probability of explosion increase if we introduce the biomass inside the meal. Of course, we try to avoid such serious, very serious accidents. So one of the possible way is to apply some HRD safety system. It is the system when the fuel fire extinguishers are connected with the detection system, and in case of some explosion detection, if the pressure is increased inside the mill, the system just initiates introducing or injection of the specific solid particles inside that avoid the explosion. Also, another very common solution is apply the fogging, the very specific water nozzles. They create the fog-like water and create some safety barrier to avoid the explosions.